On behalf of Indira Gandhi National Open University, I am welcoming you for this video lecture session. My name is Subhashish Maji, Professor in School of Engineering and Technology of Indira Gandhi National Open University. Today discussing with you for this topic, heat and modes of heat transfer. This is the 6th module of the course Thermodynamics and its application. In our earlier lectures, we have discussed the properties of a system, and mainly we concentrated on pressure, volume and temperature, and we have also introduced other properties like internal energy, enthalpy and the dryness fractions, and we discussed about the change of phase, how the system changing its phase from solid to liquid or liquid to vapor. And there we have introduced a very important property, that is the dryness fraction. Now in today's lecture session, we will be concentrating ourselves on heat and modes of heat transfer. After listening to this video lecture, you will be able to understand the concept of modes of heat transfer. You will be able to explain thermal insulation. You will be able to know adiabatic process and adiabatic system, and you will be able to understand the similarities and differences concerning heat and work. So far we have discussed about heat and work, how we can calculate work for different processes. If the process is constant, then thermodynamic work done is equal to P within bracket V2 minus V1. If the pressure is constant, we have also derived the expressions for the work done for a isothermal process. We have also derived the process for finding out the work done for a polytropic process or adiabatic process. Now we will be discussing the heat and modes of heat transfer in today's discussion. Heat is the interaction between systems which occurs by virtue of their temperature difference when they communicate. What are the two parameters needed? Temperature difference and communication. Now, heat will always flow from a body of higher temperature to a body at lower temperature if there is a communication between the two bodies. Now, if a body is having high temperature, if the other body is having low temperature, but the heat transfer may not be possible if they are separated by an insulator. So, communication is also required for the heat transfer. Now there is a sign convention for the heat transfer. If you consider a system, if the system is gaining heat, if the heat is being supplied to the system, it is considered as positive, and if there is a heat loss from the system, it is considered as negative. Now, as we have already discussed about the sign convention for the work done. Work done by the system is considered as positive, and work done onto the system is considered as negative. But for heat, if there is heat loss from the system, we consider it is negative, and if there is heat gain by the system, it is considered as positive, and heat loss is negative. Heat is defined as the form of energy that is transferred across a boundary by virtue of a temperature differences. And there are three modes of heat transfer: conduction, convection and radiation. Generally, conduction takes place for solid, convection for liquid or gas, and radiation doesn't require any medium. As you all know that we get the radiant energy from sun, and there is completely no medium in between sun and other planets. So we will discuss about the three modes of this heat transfer in detail. Heat, a form of energy associated with the motion of atoms or molecules, transferred from higher temperature objects to objects at a lower temperature. Now, if you think of the conduction, that is heat transfer for solid, then we will know about how the motion of atoms or molecules plays a vital role for the conduction method. We already discussed that there are three modes of heat transfer: conduction, convection and radiation. We have seen that two systems of different temperature must communicate if a heat interaction is to occur. We now briefly look at ways by which the communication may be affected. You might have heard about the thermos flask, and there we keep the hot coffee or hot tea for a longer period, because the outer surface is heavily insulated and it will not be able to transfer from inside medium, that is hot coffee or hot tea, to the outside. That's why we can preserve any hot item inside, hot fluid inside a flask. Now, conduction, the simplest form of communication is by contact between the system, either directly or across a separating layer. The heat interaction that occurs now is termed as heat conduction. The rate of heat conducting is proportional to the prevailing temperature gradient and is given by Fourier's law. And the Fourier's law can be expressed as small q is equal to minus Ka delta T. Now you see that what is Q? Q is the rate of heat transfer, and K is the thermal conductivity, A is the area through which the heat is being transferred, and delta T is the temperature difference. Now why minus sign is introduced? Because delta T is always negative, because if the heat transfer takes place from a hot body to the cold body, then definitely the initial temperature is more than the final temperature, so delta T will be always negative. That's why the negative sign is introduced over here, so that the heat transfer will get as a positive value. Now the proportionally constant K is termed as the thermal conductivity. It is a material property, generally large for metals, smaller for non-metallic solids and liquids, and smallest for gases. Now this is the example for conduction. So here you see that a person is holding a rod and the other end is in touch with the flame of a candle. Now if you keep for some time in this position, what will happen? The person who is holding the other end will feel hot. He will be sensing hot. Why? Because there is a heat transfer through the solid rod from higher temperature to the lower temperature. Now we see how the heat is being transferred for the conduction process. Here we see that if one end of the rod is kept onto the flame, then the materials or the atoms and molecules at that part will start vibrating, with respect to its own positions, and it will, in turn, it will supply energy to the neighboring molecules, and neighboring molecules will also start vibrating. Again, they will share energy to the adjacent molecules, and in that process the heat is being transferred from hot region to the colder region. So this is the process of conduction, process of heat transfer. Now, for conduction with modes of heat transfer, the transfer of heat through direct contact occurs any time objects at different temperatures are touching each other. As long as the objects are in contact, transfer of heat will continue until the temperature of the objects is the same. Suppose if you keep a hot body and if it is in touch with the cold body, because of the temperature difference of these two objects, there will be heat transfer. So there will be heat loss for the hot body and heat gain by the cold body, and in turn, if this process is going on for a appreciable amount of time, then finally both the temperatures of the bodies will be the same. So hot and cold body temperatures will be the same after heat transfer. Now here we are introducing one term, that is thermal insulation. In many applications, it is necessary to reduce the rate of heat transfer to small value. Examples are familiar thermos or Dewar flax, furnaces, etc. The type of insulation employed depends upon the heat transfer mode which is dominant. The equation for conductive heat flow provides the basis for minimizing the rate of conductive heat transfer. We need to separate the systems by thick layers of poorly conducting of insulating materials. These are usually non-metallic solids containing pores filled with air. Examples are glass wool or mineral wool. If it is desired to reduce the rate of radiative heat transfer, then the exterior of the container should be good reflecting surface. Now you see that insulation is required for air conditioning systems also. Now suppose if you are in a place where air conditioning system is already there. So the basic purpose of the air conditioning system is to keep the temperature of the room for the comfort of the people who are residing in that room. The heat will flow from outside to inside room, and definitely the load of the the air conditioner will be more. So in that case, you have to see that there should be proper insulations so that there will be no heat flow from outside to the inside room. Now, conductors and insulators. Some materials conduct heat better than others. Materials that transfer heat well are called conductors. So in general, metals are good conductor of heat, and wood, paper and plastics are not. They work as an insulator. So materials that stop the transfer of heat are called insulators, like styrofoam, wool, fiberglasses, and sometimes the insulators are also required because suppose if you are holding a saucepan for preparing hot tea or hot coffee or for boiling of milk. So definitely if the handle is metal, you will not be able to hold the saucepan if the handle is metallic. So in that case, the handle has to be made with some insulating material. Convection is another mechanism of heat transfer. It is characterized by the fact that heat transfer takes place physical movement of material particles from a region at high temperature to a region at low temperature. Therefore, heat transfer through this mechanism is observed in fluids. Now, how the conduction process is going on? Just you keep a glass, you keep some water in a glass jar and you put it in a gas oven, and if you heat it, what is happening that the layer of water which is in touch with the hot flame will be heated up. When it is heated, the density decreases. Because of the density is decreasing, so it will be less weight and it will move in the upward directions, but at the upper layer the fluid is comparatively cold and it is more denser. Fluid is there on the top portions, so definitely the denser fluid will move to the downward directions and the lesser density fluid which is adjacent to the flame will go up. So in this case the heat transfer will be taking place because of this convection mode of heat transfer. And generally in liquid and gases the mode of heat transfer is through convection process. Now you see that the whatever I have told, that in this please look at this figure, and here see that in this container some liquid is there and heat is transferred at the bottom section. So heat is in at the bottom, and what's happening, the adjacent layer at the bottom of fluid which is receiving heat, that liquid will get the density will be less, it will move in the upward directions, and from the upper layer, since temperature of the fluid will be less than the lower layer, so that those fluids particles will be more denser, so it will come in the downward directions, so it will be a circulatory motions. So it is a continuous movement of less denser fluids at the bottom and the high density fluid from top to bottom directions. So this is the continuous process for the convection process of heat transfer. Now convection, the transfer of energy in a liquid or gas. So this process is for only liquid or gas. When part of a gas or liquid is heated, the particle it is made up of move faster and spread out more. The moving particles bump into other particles, causing them to move faster and spread out more. Now we will be discussing about radiation. We all know that the radiant energy, the solar energy we get from the sun, and for this mode of heat transfer, the material are not required for transferring heat as we have seen for the conduction and convection. For conduction, solid materials are required, and for convection, liquid and gas, these two are absolutely required for the mode of heat transfer, but for radiations the material is not required. Even when the intervening space between two systems contains no matter, the systems are still in thermal communication. Electromagnetic radiation is transferred between the surfaces and it does not require any material communication. The heat transfer by radiation from the sun to the earth is a familiar example. Energy transferred in the form of rays or waves or particles, and we will concentrate on the type of radiations that travels as electromagnetic waves. Now this diagram, you see that we are getting solar energy from sun, and the solar energy comes from the sun, and at earth we receives, and now you know very well that solar energy we are using for generating electricity or pumping water for agricultural purpose, and the solar energy is considered as renewable sources of energy. Previously, what we were doing for the generating of electricity mainly through thermal power plant, where we used the coal as a fuel or oil or natural gas, but those resources are limited. If we keep on using coal, oil or natural gas, so in near future those fixed amount of resources may not be available because those resources are limited. But if we shift the power generations from thermal power plant or the conventional fuel like coal, oil and natural gas to the power generations through renewable sources of energy, definitely in that case there will be a sustainable growth. That means we can keep the fossil fuel for our future generations. And presently all the countries are concentrating for generating electricity through solar power. Now, electromagnetic waves includes visible light, microwaves and infrared light, and that comes from the sun and can travel through space. The sun is our major source for getting this electromagnetic and all waves as an energy. Now you see that from the picture you see that we are getting energy due to the electromagnetic waves coming out from the sun and earth, and mostly we are using this, and we will not survive if the solar energy is not available to us. Now you see that in this picture that all modes of heat transfers are explained. So here you see that there is a burning of wood and there is a flame, and a person is holding a rod and one end is in touch with the flame, other end he is holding. So he will feel the sensation of hot, and because there is a heat transfer. But if you concentrate on this picture, you will find that the person is also wearing a gloves. Why the gloves is required? Because gloves is made of insulated material, so that he can easily hold the heated rod easily. And you see the person who is putting his hand just on the top of the flame, he is also receiving heat, and that is due to the convection. Here what is happening, the air which is adjacent to the flame that is being heated and density decreases. So the low density air will move up in the upward directions, and the high density air will come to from top to bottom. So there will be circulations of hot air from bottom to top, and again there will be circulations of cold air from top to bottom. So that is the process for convection process of heat transfer. And even a person is a little bit away from that flame, he will also receive heat. That is due to the radiation, because any body is having temperature will also radiate heat. So this picture shows the three modes of heat transfer at the same time. Now adiabatic process and adiabatic system. So this represents idealized situation in which the rate of heat transfer is essentially zero. As we know that the magnitude of heat interaction between two systems may be considered to be negligibly small if they are separated by insulating materials. If the separation distance is large, or if the time under consideration is small, if a process during which the heat interactions is zero is termed as adiabatic process, while a system isolated from its surroundings as regards heat transfer is called an adiabatic system. Thus, the term adiabatic means Q is equal to 0. That means if we have already discussed about the system and that is surrounded by a system boundary, and outside the system boundary we call it the surroundings. For an isolated system, there will be no heat transfer between system to the surrounding. There will be no work transfer from system to surroundings, and there will be no no work transfer from system to surroundings. So that will be an isolated system is termed as an adiabatic process. But for an adiabatic process, that no heat transfer takes place from system to surroundings. How it is possible? Suppose there is a hot body is placed in a box whose sides are made up with absolute insulated materials. So definitely there will be no heat transfer from hot body which is kept inside to the outside. So we call it is a adiabatic system. But there are some equations are there for the adiabatic systems. So we will derive those equations in our later part of our discussion. So we have discussed about the isothermal process. For the isothermal process, temperature remains constant. We have discussed about the isobaric process where pressure is constant. We have also introduced a new term, that is isochoric process, that is whose volume is constant. Now what heat is not? It is very important to discuss the four features, characteristics what heat is not. Heat is not a fluid passing from hot bodies to cold bodies. Heat transfer to a system does not always cause a temperature rise. So we have just discussed about the change of state in our last video lectures, and there we have seen that if there is a change of phase takes place there, even if we supply heat, there will be no increase in temperature. For example, suppose the ice temperature is 0 degrees centigrade. You are supplying heat to the ice, then ice will melt. But when it is melting, the mixture of ice and water temperature will also be 0 degrees centigrade. And if you keep on supplying heat, but so long as all the particles of ice melts, till that time the mixture temperature will be same at 0 degrees centigrade, because it is the change of phase takes place. So when there is a change of phase takes place, even heat transfer will not cause any temperature rise. So it is not only heat transfer which cause a temperature rise. So you see that suppose if you want to increase the temperature of a gas which is confined to a piston cylinder or in a system, of course if you supply heat, the temperature of the gas will increase. But what will happen? Suppose you are not supplying the heat but you are compressing it, so the temperature of the system will increase even though you are not supplying the heat, because if you increase the pressure, the temperature will also increase of the substances. Now heat is not a property of a system, it is a work function. Similarities between work and heat, both are energy transfer defined with reference to the system boundary. Both are transient, they exist only during interactions. Neither of them is a property, both are path dependent and both represents inexact differentials. Now difference between work and heat. Positive work defined in terms for work. Positive work defined in terms of the lifting of a weight being the sole effect during interactions. But as far as heat is concerned, interaction occurs as a result of temperature difference between the two systems in thermal communications. For work can cause temperature rise in an adiabatic system, for heat being 0 for an adiabatic system, because adiabatic systems there will be no heat transfer. So for work there are as many types of work transfer, but for heat 3 modes of heat transfer are recognized: conduction, convection and radiation. But for work done by the system is positive, work done onto the system is negative. But for heat gain is positive but heat loss is negative. This is a sign convention. Complete conversion to other form of work is possible but complete conversion to other forms is prohibited by the second law of thermodynamics that we are going to discuss in our subsequent classes. Now let us solve a very interesting problem, and it will be clear to us how there is a heat transfer between the hot bodies to the cold bodies. So problem is this, that it is necessary to supply 10,000 liters of hot water at 50 degrees centigrade to a student hostel. Dry saturated steam at 2 bar and cold water at 10 degrees centigrade are available. So the steam and water are to be mixed directly to obtain the necessary hot water. Determine the amount of water and the steam required. Now in this case, what is happening? There is a heat loss by the steam, dry saturated steam, and there will be heat gain by the cold water. So in that process, we can achieve the final temperature as 50 degrees centigrade. Now, how we can solve this problem? So assuming constant pressure mixing of steam and water in a vessel from which there is no heat loss. From energy balance, we can say that heat loss by the steam is equal to heat gain by the cold water. Now, this is a very simple problem, that if you take the mass of steam is m s and the mass of water is mw, then the total hot water required is 10,000 liters of total hot water required is 10,000 liters, that is 10,000 kg at 50 degrees centigrade. We can write the following equations, because total mass of the mixed water will be 10,000 at the end. So mass of steam plus mass of water is equal to 10,000. This is equation number 1. And we know very well there will be heat loss by the steam will be equal to the heat gain by the water. So Ms is the mass of the steam, and Hs1 minus Hs2 is the change in enthalpy for the steam, and M is equal to Mw into Hw2 minus Hw1, where Hs1 is the enthalpy of steam at entry and Hs2 is the enthalpy of steam at exit, and Hw2 is the enthalpy of water at entry and Hw1 is the enthalpy of water at exit. Now you see, here it is given as the pressure that is given, as well as the so we can and the condition of the steam is dry saturated. So we can get the value of Hs1, that is the enthalpy of steam at the entry point, from the steam table. Now how we can get the other parameters, let us discuss further. And solving equation 1 and 2, we can obtain the amount of water and steam required. At 2 bar, the steam is dry saturated. Therefore, from the steam table, we get the value of Hs1, that is the Hg at 2 bar. This value we will get from the steam table, that is 2706.3 kilojoule per kg. At 1 bar, 50 degrees centigrade, the vapor state is compressed liquid at the corresponding saturation temperature is 99.63 degrees centigrade. So enthalpy at 50 degrees centigrade is equal to enthalpy of liquid at 1 bar and at 99.63 degrees centigrade minus Cp within bracket 99.63 minus 50. This is a simple equations, and that is equal to, because enthalpy of liquid at 1 bar at saturation point is 417.5 minus the Cp value is given 4.187, and the temperature difference will comes out to be 49.63. So Hs2 you will get 209.7 kilojoule per kg. Now change in enthalpy of water is Mw within bracket Hw2 minus Hw1, and that comes out to be Mw and Cp T2 minus T1. Mw Cp is given as 4.187, T2 is given 50 degrees centigrade, and T1 is given 10 degrees centigrade. So this will be 167.48 multiplied by Mw. Therefore, the equations 1 and 2 becomes Ms plus Mw is equal to 10,000. That is equation number 3, and the other equations you will get Ms within bracket 2706.3 minus 209.7 is equal to MW into 167.48. Of course, two equations are, two unknowns are there. So we can calculate. Finally, after little algebra, we can solve these two equations for two unknown. Finally, we will get the value of MW, that is the mass of water, that is 9,370 kg, and MS is the mass of the steam, that is 630 kg. Final solution will be the amount of steam required is equal to 630 liters, because 1 kg is equal to 1 liter of water, and the amount of water required is 9370 liters. So let us summarize our discussions. We have discussed the following, that is, we have discussed modes of heat transfer, thermal insulation, adiabatic process and adiabatic systems, and similarities and differences concerning work and heat, and of course we have solved a numerical problem so that our concept will become crystal clear.